You're watching the New Stack Makers, a podcast for people who develop, deploy, and manage at-scale software. For more information and articles about at-scale technologies, please visit thenewstack.io. Now enjoy the show.
The Cloud Native Computing Foundation, or CNCF, hosts critical components of the global technology infrastructure, including Kubernetes, Prometheus, and Envoy. CNCF is the neutral home for collaboration, bringing together the industry's top developers, end users, and vendors. Dynatrace empowers developers to navigate AI-driven development and cloud-native complexity with code-level analysis and AI-powered insights to accelerate delivery of resilient, high-quality software.
So it's so good to have another pancake breakfast. We haven't had one in many years. I don't know if it was an internal revolt about the time of day for the pancakes or just the KubeCon growth, but I think it's more the latter. The KubeCon has just gotten so big over the years, and it's really fascinating to see all the developments that we're now experiencing really this year. Kubernetes really has emerged as a leader really in AI, which is really fascinating to see. Maybe some people were predicting that many years ago, but it's a time where I think we're at this inflection point where AI really is taking a bigger role. And we hear so much about it, but I still find the subject fascinating. And so I think you'll hear a lot about that today. But I want to just let you know that the whole intent here is for the audience to participate. And so any question is a good question. So just know that. You can ask anything you want here. And the whole idea is to get the conversation moving. And I am joined by Heather Jocelyn, Editor-in-Chief. And I don't know if I've introduced myself yet, but I'm Alex Williams. I'm founder and publisher of the New Stack. I just want to say, I'm going to probably embarrass Heather a little bit, but Heather's retiring at the end of this year. So let's give her a big round of applause. She's been such a big part of our community at the New Stack, and playing such a big role in just making sure everything goes well all the time. So let's just get started right away and make some introductions. Why don't we start on the end, Kate?
Hi, everyone. My name is Kate Goldenring. I am a software engineer at Fermyon, where we focus on distributed serverless and making it lightning fast to execute your functions and secure using WebAssembly. So I'm here to answer your WebAssembly questions.
Hello, I'm James Harmison. I'm a technical marketing manager at Red Hat in our AI business unit. I focus on our AI infrastructure software portfolio across the stack, from container images all the way to full MLOps platforms. Happy to chat about the capabilities we can bring there.
Good morning. I'm Shaun O'Meara, the CTO at Mirantis. We focus on cloud infrastructure and GPU infrastructure these days.
Jonathan Bryce, Executive Director at the CNCF.
Good morning. I'm Shaun O'Dell. I am the Product Marketing Manager for all things developer experience at Dynatrace. And we're an observability platform, not only for infrastructure, Kubernetes, cloud, obviously in the realm of AI as well. But I really, really care about what developers do and how they interact. And so I'd love to talk about how we can help developers.
And before we go any further, I want to thank Dynatrace for sponsoring our breakfast this morning. Let's give them a big hand. So just as a preview, really the question is for us is, what will the new wave of AI native technologies mean for the cloud native world that's been building over the past several years? And what will it enhance? What will it render obsolete? What are the opportunities and challenges ahead? And really, how should people be thinking about how should people be thinking about AI in terms of their organizations, in terms of who they are as developers, and how do they prepare for that future? And so I wanted to start off with a question, because I was talking with Jonathan at the media dinner, a media event a few days ago, and he said, "Do you know what's really hot?" And I'm like, "What?" And so, Jonathan, tell me what you're thinking about what's really hot these days.
I'm obsessed with inference. I think that 3 years ago, ChatGPT launched, and it kind of brought AI to reality for the world at large and took it out of the realm of kind of scientists and really deep technology inside of a lot of organizations that were using machine learning, deep learning, and forms of AI. But ChatGPT, gave AI a voice and let us all start interacting with it in a very human-like way. And I think that blew a lot of people's minds. But it also sucked the air out of the room and ate up all of the mind share around how do you get to that point? What other ways can you use AI? What are the future AI native companies going to look like? Because it's not all going to be chatbots. So I think that if you just look at the fundamentals and how you build towards every form of AI productivity, you have to have models where you're taking a large data set, turning it into intelligence, and then you have to have the inference layer where you're serving those models to answer questions, make predictions. And at some level, we sort of have skipped that layer because we want to talk about chatbots, and now we want to talk about agents. So personally, I've always been a plumber, an infrastructure guy, and inference is my obsession.
Inference is your obsession. Wow, that's the statement right there. So when you're thinking about inference, I wrote a story a few weeks ago about edge AI and the emergence of all different types of models that can be deployed really anywhere, in industrial environments, you name it. So Kate, I'm really curious about the WebAssembly perspective, because your perspective about WebAssembly, because that provides an efficiency I think you get that really kind of transcends what you can do with something that maybe have a larger footprint.
Yeah, I think there's two perspectives there when you talk about edge, WebAssembly, and inferencing. One, edge, when you talk about kind of the network edge or the CDN edge, it's about getting to your inferencing as quick as possible. So a lot of people are now making extra hops that they never felt like they needed to do before. So people are adding hyper-personalization to websites. And so now loading a website includes making an inferencing call. So how do you execute that quickly? And so I'm passionate about serverless WebAssembly, and that's one way to do it. So quickly get to that function that can execute that inferencing and then get back to it. And then you can get to farther edge, so like the IoT edge or the smaller server edge, and that's where people are doing really cool stuff with WebAssembly as well. So there's interfaces out there where you can basically package up your model with your WebAssembly component and then deploy that to some hardware with a GPU and directly do inferencing and other types of AI compute and have that all bundled and secure. And so I think WebAssembly is where whenever you get a new technology, the next question is, how do we use it really, really quickly? And then the following question is how we do it securely. And WebAssembly provides the opportunity to do that by sandboxing those executions as well.
A follow-up question, related to edge, but also kind of what's kind of maybe the biggest conversation we're hearing these days is MCP servers, right? But I heard a talk on day zero where it's like, why are we talking about tools, right? Why aren't we talking about tools with WebAssembly? I'm curious in your perspective there.
Yeah, I think a very specific use case that is thriving in WebAssembly right now is writing MCP servers in WebAssembly. The MCP server spec came out in like November of 2024, and people are writing MCP servers to execute these servers, but a lot of them are targeting specific languages. So WebAssembly is polyglot. You can use your favorite language of choice that compiles to WebAssembly, whether that's Python, Rust, Go, TypeScript, JavaScript, and compile it to this .wasm bytecode. And they're highly typed binaries. So what this all means is I can basically get this interface that I can have, that's an MCP server interface, and choose my favorite language and write this .wasm component that now can run anywhere. And so there's really amazing work being done there. Some projects to name, Wasset is Microsoft's project around this. So you can quickly make MCP servers for VS Code, for example. There's a company called Faster Tools that has a product called Wasm CP. There's always the W's with the WebAssembly space. That's doing great stuff there as well. And with those, you can actually deploy those servers to Fermyon Wasm Functions, which is our platform. So you can actually distribute that MCP server globally to 24 regions. And now you can actually extend Claude to access that. So that brings that quick, fast execution, the security, and the easier developer model. And so, yeah, MCP servers is a very exciting space in WebAssembly and obviously quite new to AI in general. So one to keep your eye on for sure.
That's really interesting. Shaun O'Dell, so when we think of inference and model development, how are you thinking of increasing role we see for observability? And I'm curious about how open telemetry and other open source projects are really helping users adapt.
Yeah, it's interesting when we think about data, and I kind of take a step back. Like Jonathan pointed this out. So we've had data sets, and one of the value adds, I think, is if you've been training your data in a predictive manner for 8, 9, 10 years, now we have the ability to add an LLM and intelligence on top and over inference in that situation. If you had really bad data to begin with, right? Where are you now? So it's very nice to be able to at least say we have this information from an observability perspective. However, on the other side, it's a lot of data. And so now I think there's a kind of a fundamental shift of what do I need to get the right information about an end user? I mean, even if I go back in my day, we used to care about data locality from an end user perspective, and now we care about them as a person and what they care about their information. So it's kind of an addition to all of that. To be said, in the AI world, it's just another application, and I know that I don't mean to make it seem very simple or abstract, but it is just another layer of the application stack. And so, do we treat it that way? And I think from an observability perspective, having the foundation is valuable and important. But the technology has changed, and there's more information, there's more data. So just having that information is the key. And at the end of the day, it's about solving the problem for all of us in the room, that maybe we now have new challenges, new complexities, because we love complexity in the IT world, right? And it's just building upon that, but making it simpler, easier. And so for me, it's without that beginning foundation, we're probably in a tough spot today. And so it's just a separation, but you had to have it, and hopefully it's not too much work to get there.
Great. James, we also talked earlier in the week, and one of the interesting discussions I've been having with people are about guardrails. And we talked a little bit about guardrails and the need for guardrails. Can you speak to that a bit?
Yeah, it also ties into the observability story quite a lot as well, because we need to have some measure of observability in order to be able to implement guardrails. We have to we're seeing in agentic systems, for example, in particular, the guardrails are becoming more important than ever. As a quick example, in an agentic deployment, it's really common to enable what's called a Python REPL, which is just a place where the model can run code. Usually, models are bad at math. We've all proven that over and over again. It's somewhat funny. You give it access to a Python REPL, and now it can do 1 + 5 = 6 and figure that out pretty quick because you can just write that in Python. Guardrails are critical when we start talking about these agentic systems, because what else you can do in Python is import requests and open a session. And so when we're looking at the data that's coming in from our users, the data that's coming in from our applications, untrusted data sources, we're scanning PDFs and sending this data to agentic systems. And we need to ensure that there's nothing malicious in that content as it's making its way into the inference endpoint. And then we need to inspect and observe the things that are happening between the model, the MCP servers that it has access to, other tools and resources that are integrated, whatever layer you're doing that integration at database accesses, things like that. It's really important to look at the health of these agentic systems and understand that we're trying to control something that has so many attack vectors as we feed these large volumes of data that humans are, the reason we're doing this is because we don't want to look at them. So automated guardrails are a really critical component to any of these things. And so we do have a project out in open source called Trusty AI. We're doing integrations with things like Meta's Llama Stack for direct integration into those agentic systems and a common set of rules and things like that. But the problem space is much bigger than one tool set. So it's an architectural consideration. I think it's really important that everyone's thinking about it.
So Shaun O'Meara, I'm thinking about all the projects that we see emerging and that have been longstanding, in the cloud native community. You've been involved, and Mirantis has been involved in many of these projects. What are some of the trends that you're seeing now when you think about, the cloud native technologies we've built over these years and the AI tools we see emerging?
I think one of the key things we keep forgetting about all of this, the stuff has to run somewhere.
Yeah.
We have to orchestrate the infrastructure that all of these components run on top of. One of the big trends which I'm seeing everywhere and people are forgetting about is we're moving away from the abstraction that we came to accept as normal in cloud native. We go to a public cloud, we run our workloads, we have no idea what infrastructure is underneath that. With GPU-based bound workloads, we have to be aware of the deep infrastructure. We have to be worried about things like PCIe buses. We have to be worried about InfiniBand. We have to be worried about network speed and network performance. And as a community, a lot of what we're doing, a lot of the tools that are in this community are centered around managing infrastructure at scale. And we're starting to forget that. And I think one of the things that behooves us as we start to look at all of these great tools that are running on top of these platforms is we have to remember to run them securely, to be efficient, to manage infrastructure efficiently is going to be one of the key challenges over the next few years. We have a power problem. We're running out of power to run these data centers, and we're building them as fast as we can. We have to manage that infrastructure efficiently.
I'd love to see if there's any questions. Can anyone want to raise their hand to ask a question? We'd love to get a conversation going with the folks up here. Anyone have any questions that they have on their mind?
While they're thinking about a question, I want to just add something on to what Shaun was saying. Totally right. We know that there are power constraints. We have companies in the hardware space who have 5 years of orders that are in. So clearly the hardware and the power are maxed out. What I think is actually really awesome and a big opportunity for us in the cloud native world is software can get better and software can become more efficient and software can improve at a much more rapid pace than building a nuclear power plant. And
100% agree.
Yeah, and if you look at some of the key software technologies like VLLM, which is one of the most popular inference engines, they have continuously made huge performance gains, like many multiples more efficiency just in the last year, 6-8x kind of efficiency in the last year for running different models. LLM-D, which is a project that Red Hat launched with a bunch of partners earlier this year. It uses techniques around caching and prefill and this kind of thing that again can get you multiples of efficiency out of the same hardware. So I think that this is as you move from kind of the initial phase of wow, look at what this technology can do to the phase of now everybody wants to do it. Every layer of the stack has to get a lot better. I think the one that can adapt the fastest is the software layer, and that's what our community is really good at.
So I've been hearing a lot about this. Every layer of the software stack needs to get, it needs to be optimized to some extent. Is that kind of what you're saying? I'm curious. Shaun.
I just want to agree with Jonathan. At the end of the day, where we're going to gain efficiency, where we can move fastest, is going to be within each layer of the software stack. I mean, we're starting right at the bottom with Kubernetes. Kubernetes has become more than just a way to run containers. And if we really look at its capabilities, we can actually use it to manage infrastructure. Then we can start to use that and layer up each layer of the stack from operating system drivers to GPU operators to the inference layer. The inference layer is highly dependent on having an effective underlay system to run on top of. VLLM, LLM-D, there are other great projects out there. These are the projects that we need to be focusing on and integrating deeply into the stack as a software community so that we can achieve these efficiencies, but that we can also manage user expectations. Big deal with inference is going to be latency for user feedback. So we have to start taking these things into account as we start to architect our entire platform.
I go back to, think about 10 years of the CNCF and imagine where we would be today if we had not had the innovations and the gains and the improvements. And that comes from, I was at VMware back in 2010. So I've gone through the virtualization phase, now the cloud native phase. And I actually think from an AI perspective, we are just barely starting.
Yep.
I hear that a lot, but could you help us understand what you mean by that?
So I go back to this idea of revolutions, right? The manufacturing revolution, the industrial revolution, all of these different fundamental different ways of doing something where it either increased productivity or efficiency, right, at mass scale. And for me, in the AI world, and obviously I'm not a naysayer. I'm actually very positive or forward thinking in this manner. I don't know if we necessarily know what 3 to 5 years looks like with AI or with generative intelligence, if we want to go that route. So for me, we're only beginning, and I am not a visionary in that sense. And I don't know what it may be, but I definitely believe we are in a new realm or a new revolution. And I don't. Even if you go back in history, right? They didn't realize they were in a revolution until they're a couple of years in, and it fundamentally changed the way that we did things. And so I think we're at the beginning of those stages.
But I think I want to catch on that. What's exciting is I think we're starting to realize 3 years into this journey that people are starting to accept the technologies, understand the technologies. But one of the key things in the conversations I've been having here over the last few days is they're also starting to realize there are use cases where it doesn't apply. 100%. And that's going to be the key to making us move forward. Because we won't be trying to slam it into every use case. We'll apply it appropriately. What that killer use case is, I'm not sure yet.
So,
yeah,
Kate, I'm curious about some of the use cases outside of edge, inference that you're seeing in the WebAssembly world that relate to this discussion.
Yeah, I think I mentioned briefly the one that we've seen the most in our customers on Fermyon WASM functions, which is hyper-personalization, which hits every industry. So you can imagine you're going to a retail site and you're looking for some shoes, and you happen to be in Seattle, where I'm from, and they know it's this time of year. They may load maybe rain boots higher up on the page. That's not inferencing. That's maybe a GeoIP lookup. But then when you click into the boots after that, maybe the description has been changed to meet your needs. So maybe they change the description to say, hey, it's rainy every day. This is your everyday rain boot. Or maybe then instead you live somewhere
That's
where...
a good line.
Wow. Do you have a copy editing background? Because
there we go.
We'd like to talk.
Maybe that's the next new wave for me. But yeah, maybe you live somewhere where when it rains a lot. And so they change it to be that is the new tagline. So instead of having to have this huge already loaded on your front end of your site of they live here, this is the response, instead you look that up for the request. And ideally you have caching, so you only have to look up when you need to, just to avoid using it as only when possible, when you have to, because those can be expensive lookups.
James, I'm curious in your take on, I like the discussion about what use cases you should not be using. And I think there's more emerging out on the edge, for instance, right?
Yeah.
You don't, a guy out on an oil field maybe not be like, interacting with a chatbot, right?
No, yeah. So oil fields have a ton of AI already involved right now, as an example. They do a ton of data on like the health of the machines, lots of little sensors reporting lots of information, and then traditional classical ML interface is there. And I've had people, because in the early, so far to date, people have been trying to bolt generative AI into every use case. And I've had people say, like, how could I make a chatbot make this better? And it's like, well, I don't know that you could. That's not a case where that's going to be super productive. AI is still valuable. And one of the things that's really interesting that we're seeing is that there are things that are maturing more rapidly thanks to the rise of generative AI that apply to more traditional machine learning operations as well. Things like model registries and model attestation have gotten so much more robust thanks to the Gen AI boom, and that's still useful on an oil field. So even when Gen AI isn't applicable to a use case, I think that there's ripple effects that we're going to see that are going to make AI in every way better in all the applicable places.
Is anyone curious with the question about any of the topics we've been discussing so far?
Well, morning, everybody, and thank you for having us here. I love how efficiency has been mentioned. You spoke about efficiency throughout every single layer of the stack. Efficiency of the code has been mentioned. And of course, I have a carry bias with this question, but I wonder where else we can harvest efficiency. At Takamas, we're seeing a lot of efficiency being nested into the configuration of those layers of the stack that often go completely overlooked and untouched, and default configuration is spread everywhere. Has that been seen by any of the panelists?
So configurations at every layer of the stack.
Yeah, I can talk a little bit about that. One of the things about our higher level MLOps platform that's doing it's the one that's based on top of or built on and around Kubernetes, is that everything is API driven at every layer. The software defined network is configured behind an API. The drivers are configured behind APIs. And we move people towards infrastructure as code, where you're able to define these levels of the stack entirely in a repository and then enforce state reconciliation to match the declared intent. And in terms of like optimizing for configurations, we're seeing people move to models where using capabilities like inference time scaling in terms of efficiency, where, hey, I can use a lower precision version of this model that is less accurate measurably for easy tasks. But automatically, when more complex queries come in, they're able to be evaluated and, oh, you know what, we need a higher precision version of the model to really successfully accomplish this. And being able to enable all of that as configuration as code through API-driven everything is one of the keys that we're seeing as a successful drive towards efficiency for customers in their environments.
One of the questions I have, Jonathan, is about open infrastructure and how you're viewing it now. I think what we are starting to see is the emergence of small language models, as we've been hearing about during this show a bit. And because most of the large language models have, their APIs are not open, right? And so I'm curious on like what if you see the emergence of like OpenStack, right? And how it evolved. And there was a great dream for OpenStack, and I think in large part it's, fulfilled its mission to many extents. Then we saw the cloud native world emerge really with Kubernetes. What is the open source story going forward? Because I don't see anything that's the equivalent for, without thinking of a better term, AI native. So is there a need for another kind of like generation of the CNCF to like extend its mission, or are there needs for other groups to emerge to work in parallel?
Yeah. So this is where I think it gets tricky to use AI as a single term because it encompasses so much. We were just hearing about traditional machine learning in oil fields. Those are not new systems, right?
Absolutely not.
Yeah. When you mentioned small models as well, which I'm also super interested in, and I think that's why I feel like we were almost like captured by ChatGPT for the last few years, and we're finally breaking out of that and moving to, in some cases, back to things that we've been doing, but with a greater understanding of the utility that we can get out of them. In terms of where those communities are going to thrive and form, you have to break AI apart into the main categories, and this is why I talk about training, inference, and apps and agents. And training has an incredibly robust open source ecosystem. PyTorch has a foundation with a number of projects in it. PyTorch is 80+% market share on Hugging Face and other kind of the main model repositories. So there is a really, really strong community. That's a very, very deep technical community with a really deep technical expertise. Somebody who is maybe a front-end developer working on a retail site application is not necessarily going to be somebody who's contributing to the PyTorch core software. So this is why I think it's important to actually break AI into some subdivisions, because we're going to have a lot of different people with a lot of different categories. It's kind of like, we have database plugins and support in Kubernetes, but the database experts are writing Postgres and Cassandra and MySQL and those kinds of things. And I think that's what we'll see with AI. I'm wearing an MCP jacket actually from the MCP Dev Summit in London. MCP has a strong open source community. They're less than a year old, and have really coalesced a lot of work around how do we expose capabilities from different models programmatically and so I think we'll see various different organizations emerge at different layers of the stack.
So how does that affect your own future at
Well,
the CNCF?
Yeah, I mean, this is why I'm obsessed with inference, because what inference requires is a really strong ability to deploy, scale, observe, secure complex systems, and that's what cloud native is all about.
I'd like to just make a comment on that. One of the things we always do as a community is we're always chasing the new, which is important. Well, what I would like to also remind everybody is between Open Infra and CNCF, there's a combined almost 30 years of experience of running infrastructure systems, and especially the governance processes around open source communities. And we must make sure that we keep to those and understand those and continue to leverage those as we move forward, because we learned a lot there. We've run infrastructure at massive scale. We're moving into a world where infrastructure is growing at an incredible rate. We're looking to customers who are deploying thousands of GPUs a week. We're talking about, people are looking to put 100,000 GPUs in a single data center. We need to think about this and take into account all the work that we've been doing, because that is the base that all the new inference is going to run on top of. And we need to connect these communities and maintain them very, very well.
James.
Yeah, I just wanted to add to that, because the part of the premise for our conversation today was like, what's going on with cloud native and the AI native world, right? Compare and contrast. I don't think that AI native, or whatever the future of our AI infrastructure and AI capabilities are, could have theoretically existed without cloud native. I think cloud native, absolutely critical. People have already figured out how to solve these problems. The conversation earlier about the industrial age, the industrial age, the Industrial Revolution didn't happen by accident. There was a series of events that enabled them to embark on that path in the Industrial Revolution. It's very much the same here. We've figured out how to scale. We figured out how to manage hardware in data centers at monstrous scale. We've figured out how to do efficient things with applications like serverless deployments. And all these capabilities are coming together to form like, oh, we can do this AI thing efficiently. And it never would have happened if it weren't for everything else.
I'm going to go Shaun and then maybe Kate. Shaun, yeah.
Yeah, so one thing I want to add there is the technology, the software, the creativity is only continuing to happen. You know what we still have a problem with? People in process. So it's like we continue this innovation, and I think that's like, even if you go to the Industrial Revolution, and it started with technology, and then it evolved to people process. However, for some reason in our industry, we still go back to people process almost at every turn. And so for me, it's how do we make the lives of our infrastructure teams, of our developers, just like, how do we simplify it? Maybe go to efficiency at their scale too, not just at the technology and the hardware. And so that's something I always often think about. And I don't have the answers. I think it's just going to take time as we learn and grow. And it's an exciting time, though, to be a part of it.
So, Kate, I'm curious, in a software stack and understanding kind of the core infrastructure, right? And you might be running on GPUs that are proprietary, right? What do you see in kind of from your world as the hindrances of these proprietary technologies that play into, that you see customers being affected by? And in that, then what are you all thinking about in terms of how you start to resolve some of these issues? Because we do face proprietary issues all the time.
Yeah, I think when you hear proprietary, your solution for resolving that is to define an interface that sits on top of all of the proprietariness. And that's something that WebAssembly is, or specifically WASI, the WebAssembly systems interface, and the component model is particularly good at. It's all about a community of developers who are trying to define interfaces for something that otherwise would have been seen as proprietary. So, for example, the WebAssembly systems interface, that subgroup of the WebAssembly Bytecode Alliance, they had to define what does it mean to access a key value store. So they wrote in WebAssembly interface text, which is the language for defining those interfaces, this is what a key value store means. And so people are starting to write other interfaces to say, this is what WebGPU means, for example. This is what WASI-NN, neural networking, means. This is what just inferencing means. And so people are going out there and defining each of these interfaces, and then different communities are choosing the one that fits their need. And that's really helping democratize access to this diverse ecosystem.
Great. Any questions? Oh, Job, yay. Here.
Very curious as to analysts or the guest opinion on. We've had LLMs for a year now, over a year now, and when it started out, it was like, oh, LLMs can do everything. Well, there are certain things they can do, and certain things they do less than well, like mathematics, for instance, without some additional help. Have you guys gotten a better idea of the scope of LLMs? What things we should put LLMs to work on, and what things we should leave for other parts of AI or even non-AI?
The answer to that is it's super complicated, right? Because the things that models can do is changing every day. Reasoning models, if you guys have interacted with a reasoning model before, one of the interesting things about a reasoning model is it's the exact same architecture as a normal model. We just sort of hacked the attention mechanism that foundationally makes these models work to like pretend to monologue to itself for a while. And that brings things into its attention window that it wouldn't have said to the user and makes it more accurate. There's so many techniques that are just being invented that will blow your mind, that are changing the capabilities that they have. So I think the answer to that is I couldn't tell you exactly what things they are good for and not good for right now, but I can tell you that those things will be different tomorrow.
I think a very, very rough rule is that LLMs are generalists, kind of general knowledge. And I think where we do see people in industries moving back towards some of the previous deep learning and machine learning techniques are for specialized intelligence. And when you're like, again, why I say ChatGPT captured us. There's so many different kinds of AI out there beyond the things that you're going to have a conversation with. So Uber did a blog post, a couple of years ago that talked about their AI practices, and this is AI native was the title of this, and I think that to me it reads as one of the best examples of what an AI native company might look like. We had net native companies back in the web boom. We had cloud native companies over the last decade, and I think what's crazy is they do 20,000 training runs a month. 20,000 training runs a month. And how many models do they run in production? 5,000. So that's a really interesting ratio because it means on average they're training their models 4 times a month. Now some of the models don't get trained every month. Some of the models get trained every week or multiple times a week. Why is that? Well, what is their place of business? It's several hundred cities around the world. So they are having to build models that are updating as rapidly as our world is updating. So that's not, an LLM's not going to help them, do the things they need to do. And that's really specialized intelligence that they're doing. And it's built into every single feature in the Uber app and Uber Eats. And when I read through that, I was like, wow, this is a vision of what AI native organizations are going to look like in 5 or 10 years. Every company in the world is going to be an algorithm company, just like we've talked about for the last 15 years. Software ate the world, and every company became a software company. I think every company is going to become an algorithm company over the next 10 years.
Who's next? Anyone want to help answer that question?
I think it's been said very well. I'll just add to what Jonathan has been saying. And the way we're looking at it and the way I'm looking at it across some of the customers we have who are building AI-based services is build the models when you have to interact with a human, LLMs are great. When you're interacting with data directly in streams, traditional machine learning is fine. Quite often you don't even need machine learning. We do a lot of things without any machine learning, just basic rules. Sometimes that's more efficient. But one of the key things, and I want to pick up on the small language model discussion that started a little bit earlier, taking models and having them very specifically scoped for a use case. You don't, for example, need a model that understands 15 languages if you're only dealing with English. Narrow down the scope, narrow down the training for the models, and we'll get that efficiency we spoke about, but you're also going to increase your accuracy. You're less likely to have hallucinations in systems when they're very narrowly trained on a very specific use case.
want to build on top of that one too. The accuracy constraints, like trying to get the models to behave as well as possible. Small language models that have been fine-tuned on specialist data sets and are wired into agentic systems such that they know best how to interact with the tools. One of the problems is the domain context in which you're employing an agent often has like lingo. It often has implications that are special to that domain. I work a lot with customers in different verticals, and a financial services customer is going to fine-tune a language model to do very different things than an oil and gas customer is likely to do. And plugging them into those tools where they're able to get that rapid context, those are the kinds of architectures we're seeing where using language models is something that is beneficial, specifically when they're working in a very accurate way.
I want to just add one comment to that, because one of the things we think about with models is, traditional software is deterministic. Models are typically undeterministic, but we can bring value to models by putting them in deterministic workflows and deterministic frameworks that allow us to validate what's coming out of those models, but also put safety nets in place so that we don't end up having a system that goes and deletes everything just because somebody used the language the wrong way around.
So why don't we finish up, and I'd like to give Shaun a chance to speak, and then Kate, if you have any last thing to say.
I would say there's a lot of naysayers in the world of hallucinations, and I think this goes back to the validation there. Applying AI, LLMs, small language models, deep learning, et cetera, in context, I believe is actually where we should start. And this always goes to the conversation. It's new, it's fresh, it's the hype. So let's just go with it. Well, in reality, sometimes it's just not necessary. And I believe all of us probably have fallen into that trap a few times, where I want to test this out just because I want to test it out, or I want to try this because I can. When in reality, I could have done it in 2 minutes rather than the 6 hours it took. And I think when we think about those things, we are human and we want to try new things. We want to do things differently. But the context, at the end of the day, let's just get it done and be okay if it's not cool. But the beauty is, if we had not started this process 10, 15 years ago in a cloud native world, even the complex things we wouldn't be able to do, which we need to be able to do. I mean, I took a Waymo over here this morning. Done it a few times. If you truly understood, just go look at the technology and the ability from not only from a data perspective, but a learning perspective, an imagery perspective. Like, we've made so many advances, but it's contextual and it's valid to the point in time and the situation we need it. And we don't have to overdo it, but we like to because we're human.
Kate, why don't you take it out?
Yeah, just building off of that context word that everyone's echoing, I think that's the word native. You talk about cloud native, it's about declaratively saying this runs in this context. And edge native had its wave where people had to talk about all the heterogeneous devices out there. How do we describe how to use these devices that are different? And then when we talk about small language models, that's another type of heterogeneity that's scenario specific. So each one of these build off of the cloud native origins of observability, declarative state, and being able to scale. And that's gone from cloud native to edge native to now AI native, and keeping those principles as we go.
Well, great. Well, thank you all for this conversation. Really appreciate you being here, and thank you all for joining us at Red Prefer Breakfast. Have a great last day at KubeCon. If you like this video, please give us a thumbs up. And if you'd like to see more videos like this, you can always subscribe to our YouTube channel. We're on all the major social media platforms. You can always find us at thenewstack.io. We hope to see you soon.